Hi Year 10, this is the first of 5 lessons for the topic of polynomials. So in this first lesson we're going to define what a polynomial is, and we'll look at the terminology, and we'll look at some of the operations with polynomials. Then next lesson we'll look at polynomial division, followed by factorizing polynomials, polynomial theorems, and finish off with sketching polynomials. So this is a polynomial. You can see we use function notation, and we have a series of powers of x. Now this is called a polynomial expression, and n has to be a positive integer or 0. So which of the following are polynomials? Here we have 2x to the power of 1, so that one is okay. This one is not okay. Do you know why? This is x to the power of a half. That's not an integer. And this one's not okay either. This is x to the power of negative 1. That's not a positive integer. This one's okay, this one's okay. What about this one here? This is 4x to the power of 0, which is fine. So these 4 are polynomials. Now, polynomials are named by their highest power, which is called the degree of the polynomial. So for example, p of x is equal to 2x to the power of 5 minus x to the power of 6 plus 7 has degree 6, because this is the highest power of x. You can see how I tried to trick you there by putting it in a different order. Now we do have names for a few of the polynomials. The first one, degree 1 is called linear. It's a straight line. Degree 2 is called quadratic. Degree 3 is called a cubic. Degree 4 is called a quartic. And degree 5 is called a quintic. And anything higher than that, we can just say of degree 8, for example. Now we have learnt about functions and relations. So here we've got the whole set of relations, and within that we have the circle, which is not a function, and then on this side we have functions, including hyperbolas, exponentials, and then polynomials. So let's look at some of the language of polynomials. Now these numbers here, Pn, Pn minus 1, all the way down to P0, they're called coefficients, and you should be familiar with that. The term Pn x to the power of n is called the leading term, but it's not because it's first in the series, it's because it's the highest power of x. And P0 is called the constant term, and that's because it doesn't have an x. Now remember, x is a variable. It can take any value. Because this doesn't have an x, it stays constant. Now Pn is the leading coefficient. It's the coefficient of the leading term. And if this is equal to 1, we say the polynomial is monic. If it's not equal to 1, we say it is non-monic. Here's an example. For the polynomial p of x is equal to negative 3x to the power of 4 plus 5x plus 6, state the degree. So we're looking for the highest power of x, which is 4. The leading term, so that's the highest power of x. Remember, it doesn't have to be first. And we want everything, so negative 3x to the power of 4. The leading coefficient, this time we just want the coefficient of the highest power of x. And we need this negative as well, so it's negative 3. And the constant term, that's the term without the x, so that's going to be 6. Now, if you don't have a term without an x, that would be 0. And finally, is p of x monic or non-monic? So we look at the coefficient of the highest power of x. Is it 1? No, it's not. So this is a non-monic polynomial. Now I mentioned that we use function notation for polynomials, and p and q are common letters, and we often use r for a remainder, but we'll look at that later. So if we have p of x is equal to 2x cubed minus x squared plus 2x minus 3, we can find p of 3 just by substituting 3 for x. Putting it in the calculator, we end up with 48. Now remember, if we want to substitute in a negative, we should put it in brackets, because negative 1 cubed is negative 1, but negative 1 squared is positive 1. In the calculator, we end up with negative 8. The zeros of a polynomial, they occur when p of x is equal to 0. And graphically, they are the x-intercepts. X-intercepts occur when y is equal to 0. Remember, this can be thought of as y. So if we want to find the zeros of p of x here, we're going to use the null factor law, which states that if a times b is equal to 0, then either a equals 0 or b equals 0. But in this case, we've got 3 parts to it. And if any one of those is equal to 0, the whole thing is equal to 0. So our zeros are going to be 3, negative 2, and 4. And we also call these the roots of the equation. Now, given 2 or more polynomials, we can add or subtract them, multiply them, or divide one by the other. And we're going to look at this one next lesson. Here's our example. If p of x is equal to 3x squared minus 1 and q of x is equal to x squared minus 3x plus 1, find p of x plus 2 times q of x. Now, the only tricky part here is we need to put q of x in brackets because it has more than one term, like this. And we're going to expand through this bracket and then collect like terms. So our answer is 5x squared minus 6x plus 1. Let's try subtraction. Q of x take away p of x. This time we're going to put p of x in brackets because there's more than one term. Expanding through here, we're going to end up with negative 3x squared plus 1. And tidying it up, we end up with negative 2x squared minus 3x plus 2. And finally, let's multiply p of x minus q of x. This time we're going to put both of them in brackets. We're going to expand this out. We're going to take 3x squared and multiply it by x squared by negative 3x by 1. And then we're going to multiply negative 1 by x squared by negative 3x by 1. So with 6 terms altogether, and tidying it up, we get 3x to the power of 4 minus 9x cubed plus 2x squared plus 3x, take away 1. Okay, that's it for this lesson. In our next lesson, we're going to look at polynomial division.